Hello, let's go through the final part of representations of data. In this video, we'll be looking at different ways to compare data. So, as statisticians, there are two key features of a data set we will be interested in. We'll be interested in measure of location, and this will often be measures of central tendency, things like the mean or the median. How can I best represent the data with just one value? We will also be looking at how spread out the data, the variance, and we'll be using key statistics like the standard deviation or, for example, the interquartile range. And it's important to note that when we compare two data sets, we should always use measures which go together. I.e., we should be using the mean and standard deviation as like a pair, or we should be using the median and interquartile range as a pair. We shouldn't mix these two together because they're trying to achieve different things. The mean and standard deviation, the big benefit is that they use every value is included. The value in the median and interquartile is that they actually exclude extreme values. Okay, let's have a look at an example to illustrate this point. So, there's something called the large data set. The daily mean temperature during August 2015 is recorded at Heathrow and Leeming. For Heathrow, we're told that the sum of all the x values is 562.0, and the sum of all the x values squared, sigma x squared, was equal to 10,301.2. We'd like to work out the mean and standard deviation for Heathrow. Again, this might be something that is familiar to you, so I will pause and let you have a go by yourselves. How did you get on? So for the mean, we have the following formula which we need to learn off by heart. The mean is the sum of all the values divided by the total number of values. So in this case, the mean is 562.0 divided by the number of values. Well, how many number of values would we have during the month of August? Well, August has 31 days, so our n would be 31. Calculating gives us a mean of 18.1 degrees Celsius to 3 significant figures. To work out the standard deviation, denoted by sigma, we can use the following formula from the formula books. It is equal to the sum of all the x values squared divided by the total number, take away the mean squared or square rooted. Substituting the values from the question gives us 10301.2. Again, there were 31 days in August, so 31 data points. And using our previous answer of 18.1 all squared. And that would give us a standard deviation of 19.1 degrees Celsius, again, to 3 significant figures. And just underlining our answers there. So let's get to the comparison part of this question. For Leeming, the mean temperature was 15.6 degrees with a standard deviation of 2.01. So what can we say? Well, we can see that if we were to compare the two means of this data set, if we compare the mean of 18.1 with 15.6, we can see that Heathrow has a higher mean, and that tells us also a higher mean than Leeming. So we can make a conclusion that it is warmer in Heathrow on average. And then we can make a similar comparison about the standard deviations. And I'm realising that I've made a small mistake in that previous calculation. Decimal place was in the wrong place. It should indeed be 1.91 degrees Celsius. Well done if you spotted that before. So if we compare the standard deviations, we can see that Heathrow has a lower SD for standard deviation than Leeming. But what does that mean? Well, standard deviation is a measure of how spread out the data is. So because Heathrow has a lower standard deviation, it has more consistent temperatures in Heathrow. I want to draw your attention how we wrote quite a statistical summary in comparing the means and standard deviation, but we took the time to explain what that meant in kind of more ordinary language, to say that it's warmer in Heathrow on average, and the lower standard deviation meaning it's more consistent temperatures in Heathrow. Okay, in that example, we looked at the mean and standard deviation. In our final example, we'll have a look at the medians and interquartiles. So, question 11. Children from schools A and B took part in a fun run for charity. The times to the nearest minute are summarised below. And this will be a nice recap of what a box plot shows. We've got the smallest, we've got the minimum, and the maximum values here. And we've got our quartiles, Q1, Q through here, and we've got the median, Q2 as well. And we've also got some outliers in our data as well. So in a similar way to the last one, we'll write down some statistical conclusions and then explain what they mean in everyday language. So first, let's measure the central location of each of those for quartiles. So for school A, we can say that the median is this value here, which would seem to be about 31 minutes. And what can we say about the measure of spread? We could use the interquartile range. So we've got a value of about 25 for a lower quartile and about 36 for the upper quartile. So the interquartile range would be about 11, if I'm reading from that graph. And now let's repeat that process for school B. The median looks to be very similar, about 31 minutes. And the interquartile range, we have a lower quartile of about 26 minutes, an upper quartile of about 40. So we could get an interquartile range of 40 minus 26 of 14 minutes. Adding on the units. So what can we say as a conclusion? Well, they have exactly the same median. So we can say that the average times for both schools were similar. But what can we say about the spread of the data? Well, school A has a lower interquartile range. That means the spread of data was less. So we can say that school A has more consistent times than school B. Has more consistent times than school B. And that concludes